Okay, cool. So again, I know not everybody really understands this, but it really is as simple as that is what's set up to be enough evidence. This distance, a sample that again has to be at least this far away, or more than this far away, to show evidence that the middle isn't here. The middle is up that way, which would correlate to the percentage being higher than that. And that's the whole idea. So I set up what far enough away is, and then I go see how far away we got. That's the next step. So what's p hat? How do I figure out p hat? You divide 122 divided by 292? Yep. 122 out of 292, that's what I see in the sample. So 0.418. So there you go, p hat minus p. Makes sense. I want to see how far apart those are. Divided by the spread. This is the one we stole from the confidence interval formula. Stole it. Nobody caught us. And I just figured that out. Be careful. Plug it in your calculator. Just be careful. So 1.09. And then can you find the p-value for that? So here's 1.09. We got here. We already know the answer basically, right? There's our z-star, 1.09. So we did not make it far enough. But now what's the p-value, the area in this tail? You do it the same way as always. Careful. I mean, so that's the area down this way. 0.88 what now? It should be 0.8621. We're looking at 1.09, right? 8621, right? So the p-value would be 1 minus that. That's the p-value. So p-value is 0.1379. Which is greater than alpha. But this also tells me the same result. What's the result? Can we reject the null or not? Yeah, we didn't make it far enough. We didn't make it. We didn't find evidence, so we can't say that the null is wrong. So here we fail to reject the null. Fail to support the high. You never reject the high. You never support the null, ever. You reject the null or you fail to do that. You support the high or you fail to do that. Which one was our claim? The high was our claim. So I'm going to use this language, not you. That's it. That's how you know what words to use, right? Fail translates into we have not found sufficient evidence to support the claim that And you can pretty much just plagiarize the shit out of my stuff. Just go, what's your claim, Jeff? You feel that the to support the claim that the percentage of students with more than 2 finals on the same day has increased from previous year, bam, just plagiarize the hell out of my little paragraph, and I will not take it personally. Because that's, you just have to reference the freaking claim. So you just write what the claim is. So you guys get a little lost in there, and you're trying to make it all whatever. I have no idea. I have to tell you what the claim is, and at the end you have to reference the claim. So hey, you just pick it up and put it down. I don't feel like writing that. I just read it to you. I already wrote it. It's there. So fill in the blank. Bam. With the claim from the paragraph. Okay. So, I mean, I'm sure somebody who's either here today or not, but still in this class, would go, well, you found 0.418. It was 0.387. Your number was higher. What the shit's this? Right? I can just see my little brother saying that to me. He's the guy that's like, everything's 50-50, Jeff. It's going to happen or it ain't. Hey, James. So, what's wrong with that reasoning? Hey, the sample's 41.8%. That is higher than freaking 38.7%. What did I do any of this shit for? Yes. This is based off of a sample. And who knows, there's variation always with samples. In fact, there's a chance that I'm wrong with my result because maybe this happened by chance and it got that far, So in this case, we failed, but still there's a chance I'm wrong because maybe I just happened to pick a sample of that included less people. Maybe for real it's 48%. I just happened to get a sample that was less. So there's always that chance I'm wrong. That's what I love about stats. That's what some people hate about it, but it's the most honest math there is. Yeah?
So from there, can you explain the whole thing?
Which one, sorry?
On the same concept. Can you explain the part where you'll say, like, would this affect?
If the alpha was different. Mm-hmm. All right. So if, for this one, if alpha had been 0.10, what would change? Or let's say, not 0.10, let's say if alpha had been this is kind of silly. If alpha had been, because we have 1.09, didn't we? That's a hard one to do. If alpha had been 0.20, how do I figure out what would change if alpha was 0.20? This critical z-score, right? The definition of what far enough away is. So if you look up 0.80, you'll get that new z-score. And that new z-score is going to be less than 1.09. I would have found evidence. So that's the possible change. So really, what's the most direct change that happens if I change alpha? The critical value changes. The boundary between found evidence and didn't find evidence. That changes. I like it. And then you just got to step back and say, did my z-star fall? Did it change the results? Yeah.
Can you go over the line of test and how the wording works with explaining that?
Oh, so, okay. Did you figure out what they want from this year? So when I ask you to interpret R, here's the kind of things you can say. So on that quiz, for example, I asked you 2 questions. Interpret R, and then I ask you about the line of best fit. So this interpret R part is, R could be positive or negative. So you got to reference that. R could be close to 1 or not close to 1. R could be greater or less than the required R to show correlation. Oh, shit. So if my R had to be greater than 0.5 to show correlation, and I got, let me see if you guys can handle this. I got negative 0.93. Did I find correlation?
Yes.
Yes, I love it. Because R, give me a break. It's got to be more than 0.5 away from 0. And is this more than 0.5 away from 0? Yes. Just because it's negative correlation versus positive doesn't take anything away from it. It's almost freaking -1. So this just gives, like, now on the actual final, I'm going to be nice. And now I convert this to say r less than -0.5. Because I have to. All right. So this does show correlation, but you have to be more specific. What kind of correlation? It's negative. Strong. So strong negative correlation between the data, between the variables. R can't be correlated. R is a number. Right? The line can't be correlated. It doesn't make any sense. Two sets of variables could be correlated. Right? The amount of beer you drink and the mood you're in. Hey, they seem to be correlated. Now, when I ask you about what does it tell you about the line of best fit, there's a few different things I'll take. In this case, what's it tell you? You can talk about the line of best fit versus the data points. This would tell you what about the data points in the line of best fit? They're close. They're fairly close. They're tight to the line. Right? They're not perfectly on the line, because that would be perfectly on the line would have been -1. Right? But the data points are tight to the line, or fairly close. I like that. You could also say, based on the next question I always ask you, can you trust this line to make predictions? Would you trust the predictions this line makes? Yes, you would, because we found a correlation. Even if it was negative 0.502, I would trust it to make predictions, because I did find a correlation. Now, is that prediction really accurate? No. But it's better than just saying it's about the average, right? It improves on that. The better this is, the better the improvement it makes on just guessing the average always. So I would trust predictions made by the line. Yep. All right, those are the kind of things you could say. I'm not saying memorize that shit, because when you try to memorize that stuff, you start putting words down in interesting orders that end up meaning nothing in this language. Right? So just understand the idea and then use it. Right? That's like what does the z-score tell you? I get all kinds of interesting combinations of words. These are all the right words here. It's like the magnetic stuff on your fridge when you try to make poetry. Here you go. All right, let me go ahead and give you guys the answer key. There's 2 pages to this, so let me. Do not. Yeah, different curriculum and so forth. So, 342 students, 13% of them is what I expected them to have. Here's the second page, because that one ends at number 7.
So in 4B, this is a answer key from back when I had a different kind of question on 4B. So 4B part 2 changed to be just max and min expected values. You can see that it used to be something really interesting. Use the NAB as the normal approximation to the binomial distribution, but we don't do that anymore. You guys see what I'm saying? 4B part 2 is just the max and the min. How do you find the max and the min expected values from way back when? Yes, within two steps. It's within 2 steps. So you take the mean, you go up and down 2 standard deviations. So mu minus 2 standard deviations is the min, mu plus 2 standard deviations is the max expected value. So if you get something outside of that range, it's unusual. Do you see how that directly correlates to, hypothesis tests, where alpha now kind of defines what's unusual. Sure. Yeah. Yep. They all had the one minus that. Oh yeah, it's still printed. So just to remind you guys, on the grade sheet summary, 2 things. If there's any homework that's missing or quizzes or tests that you haven't corrected, you can still do it and turn it in the day of the final. Like quiz 1, if you haven't corrected it, you can still do it and turn it in. Now don't get too excited because it's very late. But if you get enough right, you might get a point or 2 back, depending on what your grade was. You guys understand? And it's all a review for the final. Also, please remember there's my office hours for next week and the following Monday
on there, right?